So maybe the first thing that's always worth doing for these types of limit problems is identifying what our indeterminate form is. Or sorry, what our form of the limit problem is. So in all of these cases, I want to re-emphasize that I am not writing that this equals 0 divided by 0. Okay? What I'm doing is you and I are pausing to talk about the structure of this problem before we go into working with it. Okay? So I'm pointing at this problem, and I'm going to say that if I were to go ahead and plug in a 2, which I'm not allowed to do, I cannot use, everyone see that I can't use direct substitution on this problem. Everyone comfortable with that idea? So I can't use direct substitution, but if I were to go ahead and plug in 2 into the numerator and 2 into the denominator, we would see that it had the indeterminate form 0 divided by 0. Okay. And if we were to do the same thing over here, again, we can't use the direct substitution property. Let me zoom in on that. We can't use the direct substitution property on this second limit question. Why not? Because essentially the direct substitution property breaks down because we're unable to use the quotient property, which said that the limit of the quotients was the quotient of the limits, because that property only holds as long as what, folks?
The denominator is not 0.
As long as the denominator is not 0. So in this case, the limit of the denominator would be 0, and we cannot use that direct substitution property. Okay? So this thing does not have an indeterminate form, but it has the form of a positive number divided by 0. Okay? Again, folks, I want everyone to realize, because this is a dangerous thing for me to do for you, I am not writing that this equals something divided by 0. Everyone understand that I'm not writing that it equals something divided by 0. You're not allowed to ever write that. Instead, what I'm doing is I'm pointing at this expression and saying that it has the form of a positive number divided by 0. Does everyone see what I mean by that? Okay. And over here, this has the form of a positive number divided by 0. Again, I'm not saying that it equals that. I'm just classifying these problems because I want to talk about their differences and similarities. Okay? So this first one is not a question for today's work. This is what we've been doing all along in this course. Let me zoom in on that. This first one's not a section 2.4 problem. This is a section 2.3 problem, where my first step is to go ahead and cancel out the factors of x minus 2. And we saw I justified for that for you at one point when we looked at graphs. Now we can go ahead and apply the direct substitution property, and we evaluate that limit. Okay. In this case, interestingly enough, our indeterminate form evaluated to give us a 5. That won't always be the case. It could come out to be 1, it could come out to be 0, it could come out to be does not exist, it could come out to be 17/3, who knows. Okay, but in this case, our indeterminate form evaluated to a number. Notice I didn't write what word in front of the word form here when I classified this problem.
Indeterminate.
Yeah, this is not an indeterminate form. If you look at this problem, you can predict what the answer is going to be. It's going to be one of 3 answers. It's either going to come out to be positive infinity, negative infinity, or does not exist. It's going to be one of those 3 answers. And that's what we learned in last night's pre-work. Okay? It's very critical for me that you understand that this is a completely different animal than this first problem. First one had an indeterminate form of 0 divided by 0. And we use one of the 2.3 limit techniques. For this one, we are not going to justify this. We're just going to get it down to a point, and then we're going to use a fact. And the fact is that a positive number divided by something that's very, very small but still positive approaches infinity. Okay, let me just say that again. we saw this in your pre-work. If you took 1 divided by x, if we look at the limit as x approaches 0 from the right, this comes out to be positive infinity. Okay? The way I say that is that a positive number divided by a small but what size number? Small but, the sign matters here,
Positive.
folks. Small but positive will yield positive infinity. And likewise, if we look at the limit as x approaches 0 from the left of 1 over x, that's going to approach negative infinity. Okay. And this fact is all we ever use. This fact is what we use to justify all of these other problems. I didn't prove this fact for you, but we looked at it in your graphs. And we kind of talked about this fact in our pre-work last night. We looked at its graph, etc. Okay? All right. So what do we notice about this expression here? Well, in this case, x is approaching 2. And notice if x were, say, 1.9, what would be the sign on that denominator? It'd be a small but negative number. And if x were, say, 2.1, what would be the sign on the denominator? It would be a small but... These are the easy questions, folks.
Positive.
Positive number. Okay? So what am I going to have to do with this problem? The direction of approach seems to matter here. So what am I going to have to do with this problem? What do you say, Sarah? You got it? So let's see. If we approach from one direction, we're getting one number. If we approach from another direction, we get a different number. So rather than answering this problem as a single limit question, what am I going to have to do here?
Maybe approach it from both.
Yes, exactly. We're going to have to break it up and approach it from each direction. We're going to look at the limit as x approaches 2 from the right of x plus 2 over x plus 3 over x minus 2. And we're going to look at the limit as x approaches 2 from the left of x plus 3 over x minus 2. Looks like I erased it and then wrote the same thing again. Okay. Do you see that sometimes you have to do this, folks? Sometimes you're going to have to, when you've got a form like this, a positive number, or it could be a negative number, it doesn't matter, but a fixed number divided by a small positive or a small negative, oftentimes you have to break that problem up into two pieces, and that's what we're doing here. Okay. So as I approach 2 from the right, notice that my numerator is always going to be what type of number, folks? The numerator is always going to be a positive number. The denominator is always going to be a what? A very small, but what sign number?
Negative.
Careful for approaching from the right. Try that again. So number to the right is like 2.1. So what's that always going to be? You're on the right track. What's it going to be?
Positive.
Always going to be positive. And so without any work at all, we just say that answer is positive infinity. Okay? There's no work that goes into these problems other than what I just talked through in the air with you. Other than what I drew with these arrows here. Okay? Likewise, this one's going to come out to be negative infinity. Why is that? Because as x approaches 2 from the left, the numerator's approaching 5. 5's not an interesting number, right? Signs don't suddenly change near the number 5. Where do signs suddenly change, folks? Near what number?
0.
Near the number 0, right? And so in this case, as x is approaching 2 from the left, that's a place where the sign could suddenly change, so we've got to be a lot more careful when we talk about it. A number to the left of negative 2 is like 1.9. We subtract 2 from it, so my denominator is always negative. So we've got a fixed positive divided by a small negative, and that's going to approach negative infinity. Okay. Over here, we've got a similar issue in that this had not the, notice I didn't write the word indeterminate form, folks. This doesn't look like 0 divided by 0. That means it's going to be one of these three answers. It's either going to be infinity, it's going to be minus infinity, or it's going to be does not exist. It's going to be one of those three answers. All you have to do is decide which one. And folks, I don't require any work in deciding which one. Okay, because the actual work to do this requires a formal proof. We're not going to do that, except for I'll do it one day for you and then say never again do we want to do that. Okay. So let's just go ahead and analyze this. I'm just going to rewrite it because I don't need to rewrite it. Let me just move this comment out of the way. So now we can just sort of talk through the rest of this problem in the air, but this talking through that I'm about to do is what you guys need to practice in your groups. Okay? What's as x is approaching 2, the numerator is approaching what value? 5. I don't really care that it's 5. What type of what type of number is 5? It's a fixed positive number. 5 is not a place where a sign will suddenly flip-flop, so I don't have to be very careful talking about that. It's going to be a positive number. And then what's my denominator always approaching? Well, let's say I took 1.9 and subtracted 2 from it. That's small but negative. But then what do I do? After I take 1.9 and subtract 2 from it, what do? I square it. And whenever you square a non-zero number, it becomes what? Positive. And if I take, say, something like 2.1 and plug it in, I get a small positive. When I square it, it stays small positive. So folks, do you see that this is always going to be a positive number over a small but positive number, regardless of my direction of approach? In this case, the direction of approach doesn't matter, and so we'll just go ahead and say that the answer is positive infinity. And notice I didn't have to break this down into left and right hand limits. How come? Because of this squared here. So keep all 3 of these examples in mind. First of all, don't forget the hard work you've already done. These are a certain type of limit problems, and that's what you've been spending a lot of time studying. They usually stick out because they've got the indeterminate form 0 over 0. Okay? Those are the ones that require all the techniques. They're the ones where I require you to show all the work. Okay? These 2 problems looked like a number divided by something that was approaching 0. These I do not require any work for, but I do recommend maybe giving yourself some information like I just did there. Very important though, I didn't put equals, something. All of these were just arrows. They were just me talking about the problem to myself. Or I was sharing my thoughts aloud to you. Okay? All right. I'll leave that there for a minute. What I'd like to do is go ahead and send you guys into breakout rooms and let you get started. Careful, folks, the warm-up problems are not the same as the, kind of reflecting on the pre-work. The warm-up always goes back and reviews old information, so just be careful with that. All right, let me go ahead and set up the breakout rooms. And I'm actually going to need a hand here, so let's see here. That should be right. Oops. Okay, so let's just go through. I'll just go by order here. Joseph, who was in your group? Let me stop.